So in the first question, we need to find the derivative of 3 times sine of 5 minus 2x. Just remind yourself that d by dx of sine of x is cosine of x. But instead of x, if you have a function of x, what we need to do is use the chain rule. So the derivative is equal to leave the constant alone and differentiate the function of x. So that is 3 times d by dx. This is a single function. Remember, it's sine of 5 minus 2x. So this is not a product. So it's a single function. So we need to use the chain rule. D by dx of sine of x is cosine of x. So the outer function is sine. So differentiating with respect to 5 minus 2x, we have cosine of 5 minus 2x. Do not change this. And then you go d by dx of the inner function. And the inner function is 5 minus 2x. So we have 3 times cosine of 5 minus 2x times, since it's a product, just putting parentheses, d by dx of 5 is 0, d by dx of negative 2x is negative 2 times 1, which is negative 2. Make sure you have parentheses or make it very clear to yourself that you're multiplying, not subtracting. So combining the constants, we get negative 6 cosine of 5 minus 2x. Now in the second problem, we'll take the derivative and remind ourselves that d by dx of cosine of x is negative sine of x. So we have negative 3, leave the constant alone, and go d by dx of cosine of 1 minus x squared. So this is equal to negative 3. Cosine of 1 minus x squared is d by dx of cosine of x is negative sine of x. So we are differentiating with respect to 1 minus x squared. So it is negative sine of 1 minus x squared. So we don't touch the 1 minus x squared. And then we go d by dx of 1 minus x squared, which is equal to negative 3 times negative sine of 1 minus x squared times d by dx of 1 minus x squared is 0 minus 2x. Now we put all the constants together. So the negative, 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 there are 3 negatives multiplied together. Remember, they're all multiplied. So that's negative 6 sine of 1 minus x squared. Next, d by dx, remember this is a tan function, d by dx of tangent of x is equal to secant squared of x. Notice once again that we have a constant times a single function. This is not a product. So y prime, this is tan of something, and that entire expression is one single function, and it's a function of a function. So we have leave the constant alone and differentiate the function of x. And this is equal to 5 times the outer function is tangent, is the tangent function, and we are differentiating with respect to 25x plus 1. So it becomes a secant squared of 25x plus 1. Don't touch this. And then go times d by dx of 25x plus 1. So we have 5 secant squared of 25x plus 1 times 25 times 1 plus 0. So it's 25. So this is equal to 25 times 5 is 125 times secant squared of 25x plus 1. Next, let's remind ourselves that d by dx of cosecant of x is negative cosecant of x cotangent of x. So y prime is negative 5 times d by dx of cosecant of 3x plus 7. Now this is equal to negative 5 d by dx of cosecant of 3x plus 7. That's not cosecant of x, but it's cosecant of 3x plus 7. We're going to differentiate with respect to 3x plus 7 first. So we have negative cosecant x cotangent of x, but instead of x we have 3x plus 7. And then we go times, and that's the chain rule, d by dx of 3x plus 7, which is the inner function. So negative times negative. Notice it's multiplication. Either put parentheses or make it very clear to yourself that it's multiplication. So that becomes a plus 5 cosecant of 3x plus 7 times cotangent of 3x plus 7 times d by dx of 3x plus 7 is 3. Now don't leave the constant at the end. Combine all the constants, always put it in front. Cosecant of 3x plus 7 times cotangent of 3x plus 7.